Hello students, today our topic is actually we are talking about rotational motion, right? Rotational motion questions we get at least one or two questions in the MCQ paper, and here the today question types actually I am talking about the kind of a rolling motion type questions. In rotational motion, rolling motion, that is in the rolling motion is in rotational motion question type. So let's take a look at the question types we have. Basically, a basic question from rolling motion we get from pulleys, actually pulley types questions. From pulley type questions, maybe a pulley is given and pulley is allowed to rotate, right? So there's another mass here, there's another mass there, and let's say this is M2 and this is M1. So M2 is greater or something, so it goes down. And unlike the pulley questions we did in other lessons, actually, we here in this pulley we consider there's a mass for the pulley obviously, and it is rotating. So we have to consider the motion of the pulley as well. If you can remember the other type of questions, we just found acceleration of these masses without considering the rotation of the pulley. So we assumed, what did we assume? We assume there's no mass for the pulleys, light pulleys or something like that. That point is given in the question. So you should see the point, right? So here in these type of questions, we have to consider the rolling of this pulley one time, right? And there's another rolling type of question is an inclined plane. Say there's an inclined plane, there's this mass that goes down, height is h, and you need to find the velocity at the bottom, right? Basically, if you have practice questions, you know the normal answer. If you apply conservation of energy here and here, you can easily get a v velocity equals root 2gh. That's the answer. That's the basic answer. But here, in this case, actually, we have to consider, we are not given actually a block like this, but we are given an object which can roll. So and mass is given, so it's rolling, right? That's rolling motion. So at this bottom we have rotational kinetic energy plus linear kinetic energy, half I omega squared plus half mv. Considering that, we have to find velocity. Another type. So we are doing today question from these two types. Questions may be difficult, yes, but we have to practice difficult questions. Remember that. We have to be familiar with the calculations and all that. Then only you can get the high marks. Say now, for 50 MCQ paper, first 30, first 25 questions may be easier, but the last 25 questions, we have to give a try for that. So we need to have a practice for that type of questions, and we have to, read the question, understand it, and we have to do it quickly because we are given only 2 to 3 minutes for each question, right? Remember that. So we have to practice. So I'm giving these type of questions to you, for you to practice. Remember that you learn something from this question and find similar type of questions and practice. Right? That's the key here. Right? Let's go through the questions now. Try the questions and go through the explanation. Alright students, moving into our very first question. So this is the very first question. See, we have two masses right over here. Two masses m and 2m connected by a light inelastic string. The string is passed over a pulley of mass m. A cup can be considered as a uniform circular disc. It rotates freely. Yes, just like we discussed earlier, it's a rotation question. So we have to consider the motion of this pulley as well, right? So we have to consider that, right? So let's look at the basic question from. So this is the basic question, students. We have a pulley here that can rotate around its axis, and we can write the tension here as T and T here. So we apply F equals ma for the motion of this mass m. So we can write it mg minus T equals ma. So in these type of questions, actually we are supposed to find the acceleration. And considering this mass, let's assume this is a pulley. So there's a torque because of this rotation. Actually, there's a torque. So the tension into r, the radius r here, equals I alpha. So half mr squared alpha. If you want to write alpha in terms of a equals r alpha, I hope you know this. So alpha equals AOR. So we can write AOR and T into R. From these two equations, we can simultaneous equation, we can easily find the tension or the acceleration. That's the method we are going to apply in the question given here, right? But here, student, remember one thing, the tension will be different. So let's assume this tension is T2 and the tension here, it has to be T1 then, and of course since this is rotating downwards or going downwards towards 2m direction, the direction I am showing here, so T2, we had assumed T2 is greater than T1. So let's write the equation just like we did earlier, right, using the lessons we learned from the previous question. T2 here, so it's T1 here. Let's write the equations first, okay? So consider the motion of 2m mass, we assume that goes down, so 2mg is greater, minus T2 equals m, it's 2m, acceleration e. So we are assume actually the system has same acceleration is common. Then for the rolling motion of the disk, we have two, of course you can see we have T1, here we have T2. So T2 in this direction and T1 in this direction. T2, the torque given from T2 is greater. So T2 minus T1 into the distance r equals half I omega square. Half that's given, right? Yeah, the inertia is given half mr square. Mr squared alpha we can write from A over R just like we did earlier, right? Second equation. Now we are writing the third equation. Let's write the third equation now. For the motion of mass m, so he of course T1 should be greater than mg. So T1 minus mg is equal to ma. Third equation, right? We have all the equation we want now. So simultaneously we have to solve these three equations, then we can find the acceleration. Let's simplify this first. The second equation, r, and here of course this is also r. So r and r, 1r cancel off. It should cancel off. Let's do the simplification now. This r and this r cancel off, we have 1r here, that, and this r cancel off, so we are getting T2 minus T1 equals half ma. Correct, right? Yeah, T2 minus T1. So I can get T2 minus T1 by adding these two equations, first one and third equation. You can try a different method for sure, but this is the method I'm going to follow. So I'm going to add 1 and 3. So basically what happened is when I'm adding 1, 3, 2 mg and this will, yes, T1, let's write it, T1 minus T2 plus mg remains equals, on the other hand we get 3 ma by adding first and third one, right? So I have found T2 minus T1 equals half ma, T2 minus, but here we have T1 minus T2, so it should be half, minus half. So minus half ma plus mg equals 3 ma. So I am taking this to the other side. So mg equals 3 ma plus half ma. Yes, 3 ma plus half ma, common denominator 2, so 7 ma over 2. Simplifying furthermore, a equals 2 goes up, cross multiply, 2 mg over m and m, of course you can cancel off, so 2g over 7, and we have the answer, yes, is the fourth answer, 2g over 7. Students, there are key points, but a main key point actually, we consider the rotation of the disk and we consider the tensions are not equal, right? Let's move into the other question now. Students, now we are in our second question. This question actually just like the previous question, it's in rotation motion and rolling motion. Of course you can see here this we have, instead of the pulley, actually we have a cylinder here, right? It's basically, it's almost a pulley. Remember that, that's no difference. It's easy to rotate or something like that. Other than that, this is, it's practical issues, this is easier, right? That's why they are using a cylinder here, right? There's this word dabare, right? That's a native language word, don't worry about that, and is used for drawing water from a well. The area of moment of inertia I, and its moment of inertia is given because of the rolling motion, and radius r wrapped around. So they are asking different thing from here. See, so they are asking about a time with the distance consideration, the speed. Oh, sorry, the speed of the bucket after moving a height h. So my basic steps I am telling you guys, we need to find the acceleration first. Just like in previous question, we have to find the acceleration, then we apply linear motion equation, and then we find velocity. That's the plan. Let's write the equations again. For the motion of the bucket, let's assume the mass of the bucket they are given. The bucket is m, so the mg. So the tension, let's assume it's T. So basically it's mg minus T equals ma. The equation we are familiar with, right? That's our first equation. Let's try the second equation now. For the motion of the pulley or the dabare, the cylinder here, right? So tension into T tension into R, right? Of course. So T into R, the torque, I alpha. Actually we don't need alpha here, we are alpha, R alpha, A equals R alpha, so I am writing alpha equals A over R. Second equation, we only need two equations. So let's simplify these two, then we can find the value of A, hopefully. So how do we simplify it now? Here I can write now this T equals I A over, this is same, right, capital R. So I A over R, I A over R squared, second equation still. And now I can add first and second one, so T will cancel off. So I am getting mg equals T cancel off. Here ma plus Ia over R squared. So from this I can subject simple A, then I can write it like this. Let's simply, A goes out, so m plus I over R squared mg. So acceleration, let's write the acceleration now. Let's subject it. A equals mg over, here we have capital M I over R squared, right? And have a look here, we have 1 plus mr squared, 1 plus mr squared everywhere. So basically what they have done is they have taken m out, right? Let's do the same. So A equals mg over, let's take m out of this bracket. So m1 plus, m should go in, then I over mr squared. See, now once we multiply these two, we are getting the same again, right? See, and now we can simplify, m and m cancel off. This is A, g over 1 plus I over mr squared. Let's apply linear motion equations to find V. So they are telling us it goes down a distance of h, right? And time is not given. So let's apply V equals V squared equals U squared 2as equation. V squared, that's what we need to find. Initial velocity 0, 2, acceleration we have found it now, g over 1 plus I over mr squared, and height h. Do we have the answer? 2gh over this one, 2gh over this fourth one, right? Seems like fourth one. And we need to get the root, right? Squared. So root 2gh over 1 plus I over mr squared. Hopefully it's yeah, fourth answer. Yes, 4. We don't have 2, yeah, 2 have here, right? Yes, we have. It's the fourth answer, right? So we apply the simple method to find acceleration, and then we there's an extension from this question. Actually, they are asking something else, so we need to apply linear motion equations as well here. So I hope you learned something from it. Let's move into the last question. All right, students, let's read the question. Third question, right? A thin light inextensible spring is wound around a disc of mass m, and the other end of the spring is tied to a nail at the top of the smooth plate, inclined at 30 horizontal. What's the acceleration on the disc when it is released? Right. So here actually we need to consider the rotation of this one. Yes, you might assume that there's no friction, so it won't rotate or something like that. Yes, but it's not, because of this connection with the wire. So there will be a rotation. And of course, in the question they are giving us the what are we given? Yes, I value is given. So basically we have to use it, right? So how do we apply? Just like, yeah, we don't have to panic because of this is a inclined plane. Just like the previous questions we did in a vertical plane, we have to apply the very same thing, right? Let's apply figures MA and find the acceleration, and then let's find the answer. All right. So we have tension here, and downwards we have mg sine 30. I hope you remember from the questions we have done. So acceleration is g sine theta, gravitational acceleration down. So let's apply F equals ma linearly. Let's apply F equals ma in this direction. So it's mg sine theta minus t upwards equals ma. I hope you can see that first equation. Then because of this tension, there's a rotation. T into r, right? T into r rotation equals I alpha. T into r equals I alpha. So it's they are giving us it's half mr square. Half mr square. Just like in previous questions, we are asking us to find the acceleration, right? So then A over R, it's A over R. Let's do the simplification. This R cancel off, and this R. So we are getting T equals half MA, right? Now the equation. What basically we have to do is we can add these two, right? First and the last equation. Let's add them. So then we are getting mg sine theta, t and t cancel off, equals ma plus half ma. M is common. Yes, we can remove that one. And then sine 30, yeah, of course that's 30 here, right? But sine 30, so g by 2 equals, we need to add a plus half a, 3a by 2, right? 1.5. So 2 cancel off. We can write a equals g over 3. Do we have the answer? Yes, we have the answer. I hope you have tried all those questions now. You have learned something from it, and always remember that practice makes it permanent. So what we have to do is we have to practice something correct, something right? Again and again we have to repeat trying it, so it will become permanent. So practice, right?